Yeah, okay.
Okay, we're live.
All right, so we're going to get started with the second talk for this afternoon. My name again is Jan Miksovsky from Component Kitchen, and I'm going to be doing a talk a little bit more advanced. I'll call it, let's call it Web Components 201, Designing Components for Reuse. So today's still an introductory day. In the first talk, I sort of looked very briefly at the core specs that make up Web Components, and then the Web Components JS library for backward compatibility on older browsers, the Polymer framework for quickly creating components. It's going to take time for all of that material to get digested and to make sense of it. But I thought it would be helpful for you to have a sense of what that might mean both for your own practice as a designer or a developer and for your company, the process by which you create user experiences. Because I think that components really change how you create stuff. And so the thrust of the first talk was how fundamental the changes in the way components were as a technology. In this talk, what I want you to come away from this talk thinking is how big of an impact this is going to have on how you create software, and that it will change the process and also the mindset that you bring to any given problem when you're trying to solve something, create a piece of user interface. I expect that if you're doing things with components, it will change how you approach the problem. So as before, I've got a set of topics. We're not going to go through all of this. There's a bit.ly link here that you can check out. These come from an open source project I referenced earlier called Basic Web Components that's sponsored by Component Kitchen. And on that project, there's a page that talks about some principles for creating good reusable components, and I thought that these could serve as talking points for my talk. So we're going to just look at some of them, but if you're interested, you can read the complete set, and I'll leave the slide up at the end so you can get the link later if you like. So we're going to start, dive right in. As before, I'm going to be doing just coding. So we're going to explore these through code. I'm going to take you through 4 demonstrations of building or working with reusable components. And my hope is that you'll be inspired by these. So the point is not to fixate too much on the specific scenario, but rather what it might mean in the context of whatever it is you do. So I'm going to focus first on this principle of doing one job really well. This morning we looked at a little component that did an image carousel and let you go back and forth between a set of images. And as we saw when we looked at the DOM for this thing, there are 2 buttons, and then there's this component in the middle there. So if we bring up the debugger and look inside the DOM for this thing, there's a button on the left and a button on the right, and then there's this thing called basic sequence. And I mentioned that we'd talk about this later, so let's talk about that. This carousel here is trying to do just one thing. It's trying to provide left and right navigation through a sequence of slides. Could be images, could have other content. And it's really just about that specific user interface of having either arrow keys or left-right buttons. That's the thing that it's trying to do. It's not trying to solve the problem of providing visual transitions or a number of other things. And for that, to understand how it's doing what it's doing, I want to bring up a, let's see, let's actually switch to this. Okay, so this is a class hierarchy. If you work on client frameworks, you can see these on the web. We almost never see them because we don't have a way of extending behavior or easily composing behavior. We haven't had until components. The way to read a graph like this, if you haven't seen one recently, is each of these represents a class or a component, some element. At the top, we have the most basic one, HTML element. This is just something that's going to sit in the DOM, be able to have attributes and respond to events, things like that. And then we have a succession of ever more specific classes that do something even more specific than the thing above. You've already seen some of these in the code lab that you went through this morning. It referenced component course selection or course selector, talked about these. That was revealed when you were doing the tabs. It was that tab component for paper tabs was keeping track of which tab is selected. this is the kind of thing that normally you'd say, well, okay, I'm going to have to, I'll keep track of which tab is selected. When the user clicks on one, I'll remove the selected style from this DOM element and apply it to this. And you'd think that that would be easy to do, but there are some subtleties to it, and it's nice to be able to package that up. And so the Polymer team's done that with a very fundamental class called course selection. And course selection does only one thing. It just remembers what was selected. That's the only thing it does. It doesn't imply any particular visual presentation. It doesn't apply a visual selected style to anything. It just remembers what was selected. Course selector uses that and then adds some features. In this case, it keeps track of when something's selected, it applies a selected style to it. And then if you're working with a single selection user interface, selecting something else will cause the selected style to be removed from the old thing and applied to the new thing. That's what course selector does. And that's all it does. It just applies this class. It doesn't even define a default appearance for that class. It just puts the class in there, and it's up to you or these other guys to figure out what to make of that. So each of these classes, you don't need to understand all the details and their relationship, but the point is that everything on this page is doing just one job. It's trying to solve one problem. Basic modes is just trying to show one thing. Out of a set of selectable things, it's only going to show one at a time, and the rest will be hidden. It's a modal interface. Sequence adds to that the idea of visual transitions and next previous semantics. But again, there's no particular interface that's offered that lets the user navigate. That's provided by things like the Carousel class that we looked at. So Carousel includes this basic sequence thing, and so that's going to take care of all the details of moving left and right, keeping track of which slide or image is shown, and all basic Carousel has to worry about is adding these buttons and wiring up some keyboard events. That's it. And that approach to creating user interfaces by building up complex behavior from simpler behaviors allows a great deal of flexibility. So for example, let's take a look. We'll just look, we've looked at basic Carousel. That's just one of the components that's been publicly registered. And so that was this guy, but there's another class called Basic Slideshow, which takes a different approach. It also uses this basic sequence component under the covers, but it has a very different interface. Its interface is all about timing, having a slideshow that will automatically cycle on an interval that can be paused and restarted. It has attributes like being able to control the interval, how long it's going to be on any given slide. That's the kind of thing that a slideshow does. So building that particular component is also pretty easy because it can rely again on all the work that's been done with the rest of these classes. So when you look at widgets and plugins, other libraries out there today, by their nature, they tend to try and solve a lot of problems. So for example, someone says, hey, here's my little date picker. It has a drop-down, and it has a particular visual style, and it has a particular calendar presentation. And you can, I don't know, there's a set of knobs on it. You can sort of adjust options on this thing to try and get it into different shapes. But it's fundamentally limited in what it can do, despite the fact that it has all these options. It's trying to do too much. So if you like part of it, you say, well, I like the calendar, but I don't like the drop-down part. There's no way to just take the piece you care about. You have to take this whole package. Or if you say, I like this thing, but not this visual presentation, often those things are hard to separate. So if you're designing something with components, because it's possible fundamentally to recombine components and have them work together in a predictable way, someone who's going to build a drop-down calendar or a carousel is going to take a very different approach to factoring their code. And that fundamentally leads to a better understanding of the problems you're trying to solve. It produces more maintainable code, more readable code, and allows improvements at every level. So if someone sees a chance to improve the set of visual effects, they can do that here, and every component that's using that will automatically benefit from that. So let's see how that might work. There's another kind of presentation for navigating between a set of images, and that's, I think, it might have been Apple that pioneered this, where you have a set of images and you can swipe between them, and there's these little dots at the bottom that indicate which page you're on. It's usually used for a small set, like less than 10. So let's call that a dot carousel, and let's go make one from scratch. I've got as before, I've got a simple page here. It's got a set of images, and it's going to include a new component called .carousel. And right now, that component, I've just got some scaffolding here. I don't actually have any definition. So just to get started, we're going to put in content. And so this is going to take everything, all the images that are passed into this guy are going to just be displayed. That's all that it's going to do. So let's go look at and see how that looks. Okay, so this is what we would expect. It just shows all those images. So to start, what we want to do is we want to wrestle all these into one of these instances, the basic sequence component I just showed. So that thing's going to handle moving left and right, and taking advantage of that is as simple as doing an import. And so we'll just okay, so if we just, before we go on, talk about what this is. This is saying that the content that's put inside of a .carousel tag should get put instead inside of this existing thing called basic carousel. And if we, actually, let me change that for a second. I jumped too quickly. Let's not basic carousel. We want to do basic sequence for the class. Okay, so here we have no visible UI. We see one image at a time. That's what the basic sequence should do. We have some programmatic abilities here, so I can say go to the next thing, and it'll go to the next thing. But we don't have any yet. We're going to add that ourselves. And let's also customize this. Typically in this pattern, the visual effect is is a sliding effect.
Yeah. So that next, you called next on the inner element. Your tag itself didn't support a next element yet, right?
That's correct. So yeah, so just to prove, so now we've got our visual transition. There's two main things when you're going to build functionality from smaller pieces. The two common techniques are composition and extension or subclassing. So in this particular case, I'm wrapping something, I'm composing that in, and then if I decide that thing should have all the same methods, my outer control should have all the same methods, then I'll have this component sort of delegate. It would provide its own next method and then delegate it to the inner thing. I won't have time to completely build this out, but we'll get to the basic gist of it. The thing that we want to do next is add these, the little dots at the bottom. We want to have a set of buttons, and the way that this pattern works is we want one button that can be clicked on for each of the elements in the sequence. So a way that we might write this, if we were doing it sort of in an earlier day, would have been we'd have a loop somewhere that once the images were there, it would loop up, count them, and then for each one, it would create a button element and add it into the DOM. We can do things a little more efficiently in web components and Polymer. Polymer has a template is a part of an HTML spec that I talked about this morning. Polymer adds some new abilities to template that, for example, lets you loop over a set of things. So we're going to have a template in this. So this is nested. So we're going to have, let's have a button called button, and we want to repeat this thing. We want one button for each of the items in the sequence, and the way that we can achieve that is we can give this an ID and then bind to that. as before in the morning, I sort of apologize for all the syntax and all the magic that goes on here. The key is just that this thing is going to be able to get its list of items from this thing. So if we go look at that, okay, a little small, but down here at the bottom we see we have 5 buttons. Okay, they don't do anything yet. They're not interesting yet, but it's the right number, so we're making progress. And importantly, if we were to programmatically be loading images or removing them at runtime, this set of buttons would be updating in real time because of that binding abilities supported by the underlying spec for object.observe. So to make this sort of real, we want to take these buttons and we want to add the notion of selection to these buttons. So one of the buttons is going to be selected, and it's going to have a particular, we want to have a CSS class on it that will show that it's selected and the rest won't, so they will look deselected. We could go write that, but it turns out it's already been written. In fact, we just talked about a component that does just that problem. So I mentioned core selection and core selector. Core selector, in this particular case, is exactly the thing we want. We want to have a set of elements. We want one of them to be selected and the rest to be deselected. And then when a new element is selected, the old one becomes deselected. That mutual single selection, mutually exclusive single selection, is what core selector can give us without us having to write that code. So we're going to compose an instance of core selector into this project to get that ability for free. Let's say core selector, and then we're going to just wrap these buttons in an instance of core selector. Now we want, so both this core selector and basic sequence both have a selected attribute, and we want to wire their selected attributes in both directions. So to do that, I'm going to add an attribute to this outer component we're creating, this .carousel thing, and we'll say that we want selected attribute on the sequence to be the same value, and we want the core selector to have the same value. A lot of wiring going on. So if we come back here, they still look the same, but now we've got navigation wired up for free. That just this comes from the way that core selector works. I didn't have to write any code to make that happen. And if we actually inspect these elements, let's see. So here's a button, and if you look, it's got a core selected class applied to it. And as I click a different button, that core selected class is moving from button to button. So we can now take advantage of that to actually get these things to look like dots. It just so happens I have, here we go, some CSS that does that, and I want to just bring in the CSS. There's no reason for you to watch me type all that. Okay, so this is very plain, but it's starting to look like something real. So we have a set of buttons, they're styled, they have a selection, and we can move back and forth. Now we've got part of our .carousel API is that there's a selected attribute. If I say select the first one in the set, it updates both the image that's going to be shown as well as moving the selection on the button, because all those selected attributes are wired together. So with that in place, we could apply some slightly more interesting styling. A principle I mentioned this morning that I think is pretty key to creating reusable components is to keep the styling for general purpose components to be as generic as possible. We saw this morning how you can use this shadow selector to override styling. But the fancier component style gets, the more someone's going to have to override. So if you apply, if you've got an element in your component and it's setting text shadow and all kinds of crazy CSS, and someone decides they don't want that, they're going to have to go and turn off all of that stuff explicitly, which is sort of creating work for them. So we're going to deliberately keep this styling very simple, and then let someone else apply custom styling themselves. So this isn't much, but okay, here we've got something that's beginning to approach the styling that you might expect for this particular user interface pattern. I'm going to end this particular demonstration here. The next step would be to tackle things like the ability to swipe back and forth between pages. Again, you'd be crazy to write that code yourself. You want to find a component that does that and compose that in here, so you're picking that up for free. But the idea, I think, stands that each of the pieces we're working with is trying to do one thing really well. It's when we combine them that we get new behavior. Okay, so let's go back to our list. So the next principle that I want to look at is being extensible. So Mike asked a question about sort of extending or subclassing something. So let's take a look. You can do that in Polymer, you can do that with web components, and I want to just talk a little bit about that. So extension, as I said earlier, is the ability to say, here's a class, a component that does something that I want. It's got a particular API. I want to specialize that. So I want to get everything that the base already has, and then I want to add to it, or maybe override some behavior that's provided by the base. For this example, I'm going to just go back to the little text input example that we were playing with this morning. So in this one, we had this little box that you could type in. If there was no text, it would disable the button. You could type something here, and then you could either click the button, or we added a keyboard handler, and it would let the page know that the user had pressed the button. And if you remember, this component actually has no real behavior of its own other than this little bit of interaction. It doesn't actually do anything with the text. But it might be interesting to create something that actually does something useful. So we're going to quickly create a subclass of this component that's specialized to search against Google, so that someone can just drop this in and they get a Google search box. They don't have to wire that up themselves. So we're going to replace this one. We're going to create a new component. Let's call it Google search box. And we'll import that. It doesn't exist yet, but we'll go fix that in a minute. And then let's create a new file. And we're going to start defining it now. In the morning, earlier what I did is I imported Polymer because that's how I wanted to start. I was starting from scratch. Here, what I'm going to import is actually the base class we want to start with. That will end up, because text input with button itself loads Polymer, loading text input with button will also load Polymer. It's sort of pulling in that whole chain of dependencies. And we can go create our new component. Right now it doesn't have any script. So that should be enough. Okay, so let's see. Search. Oh, and we need to extend. Okay, so here we have a Google search box. This is a specialized one. This is the base class called text input with button. And then we see one issue off the bat, which is that we've lost our styling. So we've reverted back to the default styling. As I said, there are parts of this ecosystem that are still being worked out, and I promised I'd point out where those came up. So this is one of those. The issue on this page is that we've got some styling. For example, we want buttons inside of some tag called text input with button. We want those to be blue. And that gets applied. The browser says, okay, the whatever CSS processing is going on is saying, okay, here's an example of that, so I'm going to go apply blue to the buttons inside of that. This new component that we invented, it inherits the API from text input with button, but it's got a different tag. And so CSS says, I don't know what that is. I don't need to worry about it. There are several different ways around this. I'll just share one approach, which is that you can use CSS classes. You can have a component add a class to itself, all of its own instances that you can then style against, and that will apply to subclasses as well. So in the base class, I'm going to add a CSS class with this name, and then I'm going to use that, take advantage of that CSS class. Before I was directly referencing a tag name. Now what I want to do is reference the class name, the CSS class, not the tag name. And if you look, we see these are both blue now, and the reason for that is because both of them have this CSS class stamped on them. So both the base class and the subclass end up looking the right way. Now we want to provide some behavior. We want this thing to automatically search against Google. We can begin to extend the behavior and specialize it. So we'll write some script to do that. And for people who haven't worked with object-oriented languages before, the way that this subclassing technique works is that all of this script is automatically going to work and be applied to this component that we're creating. But if we use something with the same name, like Go, that will override the default behavior that the base class is providing. So if I say that when this Go method's invoked, we want to go to Google, that will automatically happen whenever, instead of this default behavior, whenever this button is clicked. So if we go here, so I typed, I hit enter, that triggered that Go method. The Go method, instead of doing the default thing and just letting the raising an event, actually went and issued a Google search. So this is kind of an a slightly more interesting search component. Google happens to have the ability to scope searches to a site. So we could go on and extend this so that it always scoped the search to the site that the component happened to be sitting on. So if you use this component on foo.com and searched, it would only search within the contents of foo.com. And in general, become sort of a moderately interesting little search box element that you might imagine someone wanting to use, because it's giving them a leg up on having to wire all that stuff up themselves. There's I mentioned this morning that that a lot of times when someone's approaching a user interface problem, maybe something as simple as a search box, they tend to view it as a simple thing because they only are thinking about the stuff that they can see. They think about the fact that there's a text box and a button, and they think, how hard could that be? I'll just do it myself. There is, for almost any interactive element on a page, there's a lot more that can be done to make that thing better that's happening behind the scenes. So as just one example, a search box, it turns out there's a spec for web accessibility called ARIA, and there's a role that you can apply to a search element on a page that will provide a hint to assistive technologies like screen readers that that thing is the search feature on that page. I'll admit I really know very, very little about ARIA. And in a way, that's kind of the point. I mean, there's this universe of technology that I only vaguely understand, and so it's hard for me to correctly apply it in everything I do. With a component approach, you can actually have each of these components, since they're all doing one job really well, get really good at that and tackle these subtleties like ARIA behavior. So in this particular case, this search box, we want all the instances of this search box to automatically pick up that ARIA support. So we'll go and set role equals search. And now So we see here's the Google search box with role equals search set. The base class doesn't get that behavior because this class could be used for something other than search. It's just a text box and a button. It doesn't have a contract that it delivers search. But the search box does, and so therefore that's a useful role to apply. And I show this as just one example of countless examples where you can make a component better than your user could possibly imagine because they're not thinking about users with different abilities or they're not thinking about localization, etc. But the component author can, and the community of people working on the components can keep making those better. Anyone using the component would automatically pick up the benefits of accessibility, say. And that's pretty, I mean, it's pretty important. You know, people who use screen readers have money. They want to spend it on your site. And if you don't develop a site that's accessible to them, you're cutting them out as potential customers. So, you know, building with better building blocks brings a lot of benefits, among them better business success for your organization. I'll show one other trick with the search box, and then we'll move on. I mean, I can just see someone's going to go home and tell, yeah, I went to a talk. It was all about search boxes and carousels. It's really about this fundamental set of changes and how it ultimately changes your mindset. So maybe I like this search box, and I want this box to go all the way across the top of my page. I want to change the way that it's styled. There's a general principle here when you're creating components is that you'd like them to work predictably in a wide variety of circumstances. If you think about each of the HTML elements that we have today, you know, div, a, p, so on, they're real workhorse elements. You can use them in almost any combination, and most of the time you're going to get a predictable result. You can also apply a crazy set of combinations of styles to those things, and they'll work. So you can take a div and apply float and position relative and all kinds of things, and the result, after your 10,000 hours of expertise with CSS, is predictable. So the idea here is that you want components to be flexible in the same way. You want, a lot of times when someone creates a plugin that you might use, they'll include in the documentation, they'll say, oh, be sure to set absolute positioning on this thing, or be sure to set display block, or whatever, because I couldn't be bothered to make it work in other cases. You know, there is work involved there, but it also pays off if you're trying to reuse stuff. The first time you create a component, the first situation you use it in, you'll naturally end up specializing it a little bit for that context. But on the next project where you want to use that, or the next screen where you want to use that same element, you'll discover you want to use it in a different context. And rather than creating a copy of that component that's exactly the same, only can handle relative positioning, well, better to have the component itself be more flexible. So in this particular case, I'd like this search box to be able to stretch across the page. That's not too hard to achieve. I can go in here. Let's say search box, and I'll say, I don't know, but right now it has a display inline block. So I applied the style. Nothing seemed to happen. And the answer is that the component itself is as wide as the page, but the elements inside of it, like this input and this button, don't respond. That's because we didn't tell them to. When you create a visual element, there's usually two strategies for layout. One is you want components that size to their content. So like that carousel sized to the size of the images inside of it. The other approach is to have components that are going to expand to fill whatever container they're in, and then stretch the elements that can be stretched or would look good when stretched. And ideally, sort of going along with this point that we want things to work in a wide variety of circumstances, is it'd be nice to be able to accommodate both. So we can do that with a little bit more styling. We'll fix this problem in text input with buttons, so it applies everywhere, not just to our search box. We're going to add, we'll use flexbox and add some flex to that input. and we'll change the default style on the host, the component itself, its display attribute. Use flex. I like this somewhat underappreciated display mode called inline flex. And what inline flex says is that, well, let's just run it like that. Okay, so this is with inline flex. It's trying to size to its content. But if I then go and add something like, well, 300 pixels or whatever, it's going to be a little wider. And then if I go and say 100%, it'll be wider still. And significantly, if I come and get to the styles, if I turn off there's now this one CSS attribute which is flipping between, sort of determining, is this thing going to stretch or is it going to size to content? And that's a useful degree of flexibility to have. I mean, you can't have it psychically know which layout mode it wants to present, but you can sort of minimize the amount of work that's necessary to get it to behave well in that variety of circumstances. Okay, and of the second demonstration, we've got two more. Let's look at another principle and another component. This idea of being useful right out of the box, I think is an interesting one. When you create components, you can set attributes on them, for example, and you can wire up event handlers. I think it's really helpful to try and think, what could I have this component do if the author of the page didn't do anything to the component? Sometimes you'll see things where like, okay, here's my plugin. Be sure to set these 20 properties and define a method and blah, 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 in order for this thing to do anything. And that's painful. It means that it's hard to adopt and try out. And it often means that there's a lot of boilerplate that's going with that plugin, that everyone has to write a minimum 20 lines of code to get the thing to do its first trick. Instead, you want something where you can just put in the tag by itself and get something reasonable. And to show an example from a different domain, we'll look at another registered component. This one's from the domain of calendaring. So here's a component that shows a calendar. Let's open that up. It's by design not trying to be very flashy in its visual presentation. It's just presenting a calendar for 1 month at a time. You might already guess that it actually doesn't do all that work itself. So there's actually, this component has its own little constellation of classes. Here at the bottom we have the calendar month. Calendar month, if we look at this thing, it's really got month and year at the top, then a set of headers for the days of the week, and then a block of dates. And so we see that reflected here with these three components that it includes. And each of them then delegate part of their responsibility to other ones. So for example, basic calendar week is responsible for laying out a single week in that calendar. This is sort of just any reasonably interesting interactive element will probably best be implemented with a set of closely related cooperating classes, some of which you'll provide and others will come from places like Polymer's core selector, things like that. So this is an attempt to solve this problem for calendars. You could say that's not that big of a deal. This calendar has an interesting trick. It is compatible with a library called Globalize. That's a open source project managed by jQuery. They've got this library of about 350 cultures and languages around the world that include things like hints on how that culture or language prefers to see time represented. Do they like the month first, the year first, things like that? So here's this library. It turns out, so there's a lot of different cultures defined by that library. And what this component is doing is adding to that. It's taking advantage of that and deciding what those preferences mean in terms of a month calendar. Basic calendar month is trying to be good at being a month calendar. It's not trying to be good at understanding every culture's language preference or date preferences. So globalized defines things, for example, the first column here on the left, in North America, most Americans expect to see Sunday there. That's just, you'd think that that would be a worldwide standard if you never left the US, but that's not the case. If you were in, say, the UK, you would expect to see Monday, most likely on the left. You know, that's just talking about things like the layout. There's also, of course, the labels. So let's look at French. So, you know, the French would want to see not only Monday be the first day, but they also want to see, of course, French names for the name of the month and the names of the days of the week. There's many stuff in here. We can look at Japanese and see how a Japanese culture might want to see a month calendar, or even, let's see, Arabic in Saudi Arabia. So they like to have the first day of the week be Saturday. Who knew? They want Arabic labels. They'll read right to left. And you might have wondered in this little graph, like, why is there a component called basic month and year? Like, why would I need to do that? If I had the month and the year, why don't I just show the month and the year? Well, in a right to left language, you'd actually want to show them in the opposite order. This talk, this talk is not about calendars. This talk is about building up complex behavior from simple behaviors. In this case, this is a level of detail that almost no calendar user is going to want to go through to make their calendar flexible and global and world ready. But by building up from a component where someone's invested time in the component, they get that for free. Just like people are finally coming to realize that on the back end in the server world, if you're dealing with security and encryption, you would be insane to write your own encryption library. You would, in fact, now you'd probably get fired. Like, you want to use an open implementation because it's going to be that community that's going to provide something that's really solid. And yet, throughout the web, there's like a billion date pickers where people are sort of saying, here's the presentation of a month, expecting that that is somehow universal across the planet, when in fact it's far from that. So to talk about this idea of having something be useful out of the box, I've got a page here. It just shows an instance of this basic calendar month. And if we open up a page that uses it, we'll see. Okay, so an instance of it, all I had to do was put in the tag, and I get the default thing. And then there's attributes I can send on it to change its behavior. I can say, show its particular date. I could wrap it with a navigator, some kind of UI for moving between months. I could put it inside of a drop-down date picker. I could use it in a lot of different ways. I want to talk about how this component, it has a pretty neat trick for extensibility. And it's a pattern that you might find useful for some of the components that you write. So I want to look at that. In a calendar, you often don't just want to show a calendar just for kicks. You actually want to show some data in it or make it interactive. So it could be you've got a flight reservation system and you want to let the user pick the dates that they're going to be traveling, or you're maybe a calendar company, you're trying to render calendar data. Show here's a schedule of upcoming events, something like that. So in the plugin world, there might be a limited set of parameters, like maybe your plugin supports an array of strings, of 31 strings or something, and that it's going to put a string next to each one of these dates, and that's the level of data that it can represent. And then someone says, well, that's not enough. I want to show 2 strings, and they're like, okay, you can have 2 arrays, each with a string, and I'll show those 2 strings or whatever. And it's very sort of hard coded to a specific set of situations. This calendar has an interesting trick, which is that the class that's used to render the day is actually replaceable. So you can define this class basic calendar day has its only contract is that it accepts a date and then does something with that. That it, maybe in this case the default behavior is it just shows the day of the month that goes with that date. But we can do anything we want. So we can make a custom calendar. And so we're going to quickly create a calendar that presents custom data in this structure. I don't actually happen to have a rich source of interesting calendar data, so I picked Sometimes on wall calendars, you'll see the phase of the moon. I'm like, okay, let's show the phase of the moon on a calendar format. So I went out on the web and I found some really fascinating math for calculating the phase of the moon for a date. And because I love components, I packaged that up into a moon phase component, because we love components. So with that, I can say, we're going to use yesterday, because it turns out today is not an interesting lunar date, but yesterday was. And let's style this thing for a second. So that guy, so here's an instance of that component. It shows that yesterday, the 14th of November 2015, was a last quarter moon. And that's all it does. Given a date, it'll just show that the right icon after having done all that math. What we want to do now is take this and stick it into the calendar. So we're going to use some of the tricks that we've already seen. I'm going to create a component called calendar day moon phase, which extends basic calendar day using the technique that we saw with the search box. So it's going to get its behavior. It's going to be able to support a date attribute. And then it's going to host an instance of this moon phase component and pass the date to it. It's also going to show the day of the month. And so with that, let's see. Actually, let's see just what that component looks like. So an instance of that chrono, a single instance. Like this, so it shows the date, the 14th, and the moon phase as of that date. So now we've got one instance. What we want to do is plug that into the calendar. So we'll take this guy, get rid of that, and the documentation for this calendar month describes a property called day element. Day element takes the name of another class that's going to be instantiated for each of the days of the month. So we'll say day element equals a calendar day moon phase. So here we have a custom presentation showing custom data inside of this calendar structure. And the same technique could be used to show data coming from a server. It could be used to provide interactivity. So we could have anything we could do in a component, we can now drop into calendar form. So if we want hover effects or pop-ups, anything like that, expanding and collapsing, all that, anything you can do in a component, you can now stick into this structure. The calendar here is behaving, if you're familiar with the concept of generics in programming language, it's sort of like a generic component. So you have the idea, for example, in generics, you might say, here, I've got a stack, a generic stack, and then you can say, well, here's a stack of user objects or a linked list of accounts, things like that. So here, you've got a calendar, but it's a generic calendar. It's a calendar of moon phases or a calendar of hotel room availability, whatever it is, whatever calendar data you want to show. So that's kind of an interesting way to build something that's extensible and to look at, in almost every interaction problem that you've got, there's a chance that what you're looking at is not just one problem. There's often a general problem and then a specific instance of that problem. Because there's only a few hundred different common patterns for user interfaces. Like if you drew a list of like all the different techniques people use to get stuff done, they say, well, there's toolbars and menus and dialogues and swiping and pull to refresh and infinite scrolling. There's like it sounds like a long list, but it's really finite. There's maybe 200 of those. So when you're creating UI, you're usually creating something that follows one of those patterns. And instead of having to wrap up your domain of email or supply chain management, whatever, and wrapping that up with infinite scrolling, say, you can sort of pull those problems apart. You can get solve the general problem, or maybe find a solution to the general problem, and then just focus on whatever is unique about your domain. So actually, for the last little demonstration, I actually
So like this calendar then had to explicitly say, I'm going to allow for like a shim to be used as an internal component and accept that.
Yeah, so yes, that was work that the component author had to do that accepts that tag and then says, okay, I'm going to instantiate that for each of these days. So that's a degree of flexibility that needs to get put in. And that's not to say that everything you're going to write is going to be that flexible, but just to think about it in terms of like, well, what's really the general problem here that I'm wrestling with, and what's the specific problem? If I'm showing hotel room availability in a calendar, there's the calendar general problem, and then there's hotel room availability as a specific case. And you may find other patterns where you're able to factor your UI that way. Before we leave this, I just wanted to point out, so of course, since this was done with this class, I can then say, well, let's look at a French lunar calendar or Arabic in Saudi Arabia, and all the globalization work gets applied here. So by building on top of these building blocks that know a lot about their particular domain, I'm able to leverage that. I may not even be aware that that ability exists, but as these components get better, certainly my users can take advantage of that. Earlier this week, as sort of a proof that this all works, Google they had a new release of Polymer, 0.5.1, and they had a new component that they were talking about. It is called, I think it's, core scroll threshold. So I mentioned infinite scrolling as a general user interface pattern that comes up a lot. And they've got a component here. It just shows numbered divs, but as I scroll, I'm not getting to the end of the list because it's just adding more and more numbered divs as I scroll down. And what core scroll threshold does is it's an abstract component. It has no visual presentation. It will just monitor the scroll position, and when the amount below the fold drops below a certain threshold, it fires an event saying, hey, you need to put more data on the page if you want to let the user keep scrolling. So I thought, well, that's kind of cool. I have here, I have this idea. I already have a component called basic calendar week. That's a row. Maybe we can do something with that. So here I went and created a component called infinite calendar. I just did this yesterday, so we'll see how this goes. It includes imports core scroll threshold, as well as the component called basic calendar week. And then its template is, it's got some style and stuff, but really the core template is very, very small. It's basically saying, I want to keep track of the scroll position using this core component that the Polymer team provided. That is going to trigger an event when we're running out of room at the bottom, and it's going to trigger a method called add week, and that's going to create an instance of this basic calendar week and add that to the page. So we back up. So here we have infinite scrolling calendar, and I can scroll far into the future. This basic calendar week was not designed for this particular purpose. So for typically in an infinitely scrolling calendar, you'd need some way to indicate the delineation between months. So one solution there might be that you want the first day of the month to show the name of the month, say, something like that. So as we just saw, that would just be a matter of creating a custom class, a subclass of basic calendar day, and specializing it so that it knows to show the month or not, shows the month for the first. And just like everything else, we can sort of stick these things together. Try like day element. I'm sorry. Okay, so now we have infinite lunar calendar, and we could have an infinite lunar calendar with the first day of the week being on Saturday if we were in Arabia. So you know, that you can sort of see how building with these blocks allows us to get a fair amount of functionality with not a lot of investment. I worked on a project once where we had a calendar, and it was you had a page through it. There was like a next page, previous page, and we wanted to upgrade that and support infinite scrolling. And that was a 3-week project for someone to wrangle our calendar visual presentation, an infinite scrolling module, and a set of AJAX calls to go get data and get that all to work. So that was 3 weeks worth of work for a highly experienced engineer. And now this is, I don't want to say that it's trivial, but the point is that because I'm building with better pieces, I can more quickly snap together something much more quickly. So that's it for the code demonstrations. You know, for this talk, like I said, the thing that I want to leave you with is hopefully an impression that this will change the way in which you approach building software. Once you've started using components and really sort of absorbed what they mean, you'll find that when you come to a particular user interface problem, maybe a designer brings you a screen, your first instinct is not like, okay, I better start roughing in divs and wrangling them into position, but rather to step back and say, well, what's fundamentally what's happening in here? What patterns are we using? Well, we've got, you know, we want to have a set of pages, or we want to be able to swipe between things. We want to have cards that pop up. We want to expand and collapse. Whatever the user interface patterns that are going on, you'll want to have a conversation about those and an understanding of those, because in many cases you'll be able to reuse implementations of those from somewhere else. And even in the case where you're going to have to build it from scratch, you're better off keeping the abstract thing separate from the specific case. So maybe you're the first person in the world that's ever going to go build expanding and collapsing regions or something. It's still good to treat that as its own problem and then create a separate component that uses that to solve your specific need. Because then you'll have a new tool in your toolbox you'll be able to use the next time you do that. Companies tend to have fairly consistent tricks, visual languages, like they tend to like certain answers. Apple likes having little dots below a set of things that move left to right. Like they just use that all over. If you go to the Apple Store website, you might find that just because they like that. It's part of their vocabulary. And so your company or your organization undoubtedly has a set of tricks that it would like to reuse from place to place. And long term, I think where this leads, and I'd encourage you to think about, is you know, what it means for your process and where you spend your time. So I've done analyses several different times of projects looking at the amount of code that was written to re-implement, to reinvent solutions that had already been done before. So if you do an analysis of a code base and you say, okay, this whole file, menu.js, is building a menu bar. Like, that's been done a million times. So let's put that in the pile of stuff that's been done before. And then if someone has a piece of code, maybe your website does recommendations for building contractors. And so if you find a chunk of code called contractor.js, like, okay, let's put that over here. That's special to our domain. And roughly speaking, about 50% of the code in any project is going to be in the pile of stuff someone else did somewhere else. You could also label it stuff we wasted time reinventing. Or maybe your CEO would say stuff we shouldn't have spent money on. So the idea here is that you know, by working with components, you'll be able to take that 50% that's been, for the last 20 years of the web, reinventing stuff that's been done many times before, and to some degree reduce that amount of time that you're spending. Now, there is still time understanding the components that are out there and playing with the components and figuring out if they're going to meet your needs. So it's not like you can take that to zero. But you can reduce that quite a bit by building with building blocks like core scroll threshold. Boy, it saves a ton of time to not have to solve that problem again. And what that means the sort of the greater impact for you and for your business is that means proportionally you're going to get to spend a lot more time on the problem that your company is about. Like if you're building a company on, that's recommendations for building contractors, like you want to spend as much time as you can on that problem because that's what makes your business unique. You don't want to spend your time on menu bars and dialogues and things like that. And components is a way to get there. It's a way to sort of begin thinking about it so that you get to spend as much time as possible focused on your users and their needs. So with that, I think I can take some questions again if there's interest. And as before, I'll be circulating around during the code labs. Yeah.
Is there a facility for sort of validating the interface of past objects? I mean, when you're swapping out things, you're effectively using the interface to use it. So what happens, first of all, what happens if you pass something that doesn't provide, say, the attributes that you expect, and then is there a design pattern to help fix that?
So there's no, this is maybe the first instance of a design pattern for web components. I haven't seen other web components work in this particular way. So this makes the naive assumption that the class that's being passed in has a date property. So you'll just see something break in the console. It'll say, throw an exception saying this, the date doesn't exist, the method or property doesn't exist. That might be actually a fine answer. I mean, it's maybe better to have that thing break right away rather than silently absorb it. But I don't know if there's anything more sophisticated. It's not part of Polymer and it's not part of web components. It's more of an emergent property of this ecosystem that this becomes possible. So exactly where you want to take that is going to be up to you and your team. It may be that at some point a framework like Polymer has special syntactic sugar to handle cases like that if this pattern becomes popular. But right now that's really something that'd be up to you. Yeah.
Is there a way to make the component return some sort of creative value to a non-web component?
Sure. So the question was about having a component be able to sort of not just say strings or something, but be able to be manipulated programmatically and return more complex objects. Yeah. So you can do. I'm trying to think of an example from an existing HTML element. Most of the properties that they return are just going to be, well, you could have something like, you could say what's the parent of something and it'll return you a DOM node. You can return anything. So if you have, attributes tend to be strings, but you can have a property. You can write a getter setter property on a class that returns business data. So you could have a component called user selector that uses core selector to let someone select from a list of users, and then it can have a property called selected user that returns that business object, a user business object, rather than a string. So you'd be able to do that. Okay. Sure.
So multiple inheritance or mixins or interfaces. Where's that?
So this is the degree of the way in which you extend classes with web components is just the way that you do it with JavaScript. It's prototypal inheritance. So when you say extends equal, you're extending some other class by setting a prototype on your class to point to an instance of that class. So it has all the same behaviors that JavaScript programmers use today. You can have mixins, so there have been people that have created mixins that are meant to be used with web components to add a particular ability. There's no sort of strict multiple inheritance sort of definition of what that means. It's all based on JavaScript.
So there's when you look at these kind of the constellation of elements that all work together. I mean, I can really appreciate how you have abstracted all the minimal things apart there. But oftentimes when you develop systems like that, you find that they really don't perform well. There's so many like interface boundaries that you end up having a lot of performance issues with a design like that, and you end up having to flatten things out to get them to work well. Do you have any experience with this yet in this domain, whether that's an issue?
So far, I'd say that I haven't. I'm trying to think of a case where the question was about performance and whether about factoring your UI into all these components is just going to create this plethora of components, and will that have impacts on performance? It certainly could. I mean, if you factor poorly, or if you're creating for every day on the calendar you've got 100 things behind it, like at some point the browser is going to begin to bog down. I can't think of many cases where the factoring I've chosen has proven to be sort of the root of a performance bottleneck. I mean, the truth is that browsers are pretty fast. Even if I'm running the infinite scroll calendar thing on my phone, I can scroll away, and it's doing a ton of work. There's the week, and then the day, and then the moon phase, whatever. It's doing a lot, creating a lot of components for every row in that thing, and it's still fast, to the point where that would not be. I would not invest time in trying to make that faster. There are probably other places which would be bigger performance bottlenecks. There is this. Once you're using these bigger building blocks, of course, there is this challenge. Someone can go, if you look at the components that people register today, someone can register a component that says, here's my spinning 3D globe component, and you can import it, and then that thing pulls in like a huge library for 3D rendering or whatever, and that thing can be slow. It's done, it's all particle effects or something, and so that thing can be slow just because it's one component doesn't mean it's going to be fast. So I guess I'd say I haven't personally encountered cases where that's been a big bottleneck, and I've found that the payoff of being able to understand where all the logic is often worth it. I was talking to someone else a bit in the break that even if you don't use components written by other people, like I've talked a lot about reuse, I still think web components are a huge win, even for a development team that's building its own app from scratch, just as a tool for organizing your own UI code. It's just a really sane way to clearly delineate what part of the code's doing what. Yeah.
So as you were showing some of the stuff there, you have one component referencing the reuse application. And you're saying that obviously if you already have Polymer included in the parent one, and you include it in its additional version of that.
Yeah, so the general question is, if you use HTML imports, you have, say, component A includes component B, and both A and B then try and include C, what happens? I think it's a general question. Polymer is just one example. The answer is that HTML imports are deduplicated, so the browser will see that you're trying to load the same thing again and won't do it. I don't know where in the stack it decides that it already has it, but it won't load. You'll see one request, for example, in this one, if you looked in the network tab of the debugger, you would see one request to load polymer.html. That's both a strength and a weakness. The strength is that you're efficient. So if you have like on a site like Component Kitchen, the site that we've built, we've got a collection of 60 components, all of which are trying to load Polymer. Well, we're only loading Polymer once. The disadvantage is that if you're coming from a platform like Node, for example, where you have a require statement and you're loading something, you can have different modules loading sort of different versions of a library, for example, and that's currently not possible. Like you can't have one component using Polymer 0.5.1 and a different version of some other component loading Polymer 0.4. So it's a flat space of components that you're loading. So if you try and load something twice, it'll only get loaded once, but that means that if you're trying to load something, with two versions, I think the first one wins, and the second time it'll say, no, I've already got that file. So that can create some that would fall into the 5% of headaches that I've run into when using web components, is beginning to think about dependency hell, like how to avoid having multiple versions of stuff that get loaded in a single page. Okay.
So say you're like starting a new project and you think, oh, this feature shifts so much, you could write something for this before. You want to find like a web component. Like, what's the easiest way to build on that? I looked at your website and you guys have like the catalog. I'm sure there's more. And you don't know like almost it's written. You know, how good is it? Is it like following best practices? You know, is there a good way to find?
Yeah, I mean, so obviously my answer is biased here. So Component Kitchen is the place. I mean, we set out to build a catalog specifically to solve that problem. You can see what it looks like today. Today it's just looking at the set of components that were registered with the Bower Package Manager, but our intention is to expand that to cover all discoverable web components, as well as to capture some of the community feedback that you're talking about, like does it actually do the job that it says it's going to do, and what comments and things like that. So if you're interested, follow us Component K on Twitter, and you can keep up with us. We also have a blog where we publish component reviews about once a week of components that we found to be particularly interesting or demonstrate some interesting concept. That's about as good as it gets right now, and we'll be making that, sort of pushing the state of that art, but there's not some other site. If there were, I'd be trying to compete with it. And then maybe let's do one more question, then I'll walk around afterwards, but I also want to make sure people get a chance to dive into the code lab. So let me just take one more question, and I'll come up to you afterwards.
So if we have hundreds of components we're using and we're serving it up on a mobile site, is there a way to package them all for production?
Yeah, so the question was about packaging components. So if you have, if your page loads 10 components and each of those load 10 components, you're going to end up with hundreds of network requests. I found that for local development, that's usually fine, but obviously for production, particularly on a low latency connection like mobile, you want to do better than that. The best answer right now is from the Polymer team. They have a tool called Vulcanize. You can think of it kind of like in the old days. It's a little bit like a linker. Basically, you point it at a web page and say, package this all up for me. And it chases down all of the HTML import statements through these files, concatenates everything into one big HTML file, puts them in the right order, and then what you end up with is a single HTML file that you can load that has all of your resources in it. So we use that on my site to take our collection of 60-odd components and put them together. And like in the days of linkers, if you remember, there's actually, you end up creating sort of chunks. You sort of put like, okay, here's one chunk of 30 components that are needed by all of our pages, but then here's a chunk that's only needed in this section of the site. So we're going to break them up like that. And that's what you can set all that up in Vulcanize as well. So why don't we turn over to the code labs, and then I'll come around and answer other questions.
Get that. I lost my link again.
So before we kind of set you all loose, there was just really one other thing I'm just going to touch on, and it's not necessarily something you have to do, but since Polymer is very focused on kind of the mobile experience, and I think a lot of people are trying to target the mobile platforms, just to make you aware of some of the tooling that's in Chrome for dealing with mobile, debugging mobile, and understanding how your site's going to look on a mobile platform. So if you open up DevTools, go to the More Tools, Open Developer Tools in Chrome, you'll see this toolbar, and there's a little picture of a mobile phone in the corner. And if you hit that, you will actually bring up an emulator, and this has been improving a lot, I would say, over the last 6 months in the user experience of this, and how you get to it, and what kind of options you have. So you see, you have like a selector here. Bring this up myself. I'm gonna go meta on it. So you have a selector, and you can choose different devices, and you get all the resolutions of this particular device, and it'll emulate, if you're testing against a website that is using some sort of if it's using the request tags to tell like what browser you're targeting, I think you can emulate some of that stuff as well. But for our purposes, like doing pure client side, you really just want to get the kind of display resolution right, and then see how things are wrapping. And you can also emulate touch events. You can see you can grab onto pages in here and see how they behave with touch events as well. So that's one thing to be aware of. And I think if I close this, it goes back to kind of web mode. That's kind of the easiest way to do like mobile testing, and I think probably 90% of what you can do is going to be faster that way. But a lot of times you really want to get on the device itself and see what is the experience and debug while you are using your device. And obviously, most of your mobile devices don't have keyboards, and so there is a facility in Chrome for actually turning on this USB debugging. And let's see, I think I lost something in the way this page formatted. You go to Chrome://inspect, and well, let me first start off on the phone. You have to turn on like for an Android device, which is mostly what I've been testing against. For Android, you're going to have to turn on USB debugging, where you actually go to the settings and you go find about this device, and then you click on the build number 7 times. I don't know if anyone has experienced that. And then Android gives you this very satisfying pop-up that says you are now a developer. And so that's fun to do. Once your device is on, then you tether it with a USB cable to your computer, and then you type in Chrome//inspect, and you'll get this little window on the lower left, and you click on Discover USB Devices, and what should happen is that your any device you have plugged in there now starts to get listed underneath here with all of the tabs that it has open. You might have to like run Chrome on the device too. Now this one I would say is a little buggier. I've had mixed experience with getting this with mixed versions of Chrome on my device and on my laptop, and so this can be a little bit more frustrating. But once you see that display, then you can click this port forwarding button, and what you want to do is this is so that you can actually run a local web server on your machine, and then access that local web server from your device. So it tethers the network connection kind of through the USB cable to actually hit the local web server, so you can run against that instead of having to host it somewhere on your local network and worry about connectivity from your phone actually to your development server. So for the port forwarding, that left-hand number, the 8080 that I have here, that's going to be the port on the URL that you would go to on the phone, and on the right-hand side is the port that is going to be that your web server on your local device is actually exposing. So in this case, I have localhost 51792, which is usually the default that I get whenever I run the Chrome Dev Editor. So then I'm going to map it to a lower port number over on the device. And again, and then make sure you click on the Enable Port Forwarding checkbox at the bottom of this dialog, which kind of mysteriously is like, I don't know what else you'd be doing in this dialog if you didn't want it turned on, but that's there. And when you do all that, there is one more thing. First of all, you should then be able to type in. It's a little hard to see here, but right next to the Chrome version, there's a Open button. So the easiest way to open up a web page once you've got the phone connected is to type in a URL here using that 8080 port number. And you can see an example here. I have the sample unquote here going to localhost :8080, and that's to that Polymer app sample. And so that will actually, you'll be able to see it on your device itself. But even cooler, if you hit the inspect button down below there, you will actually see a mirror of what you see on the device as well. And it opens up now your developer console. So you're seeing, a mirror of what's going on the screen on your device. You can actually click on that and do touch events over it, and then you have a full debugging console that you can use on the right as well. So, so this is really kind of a godsend for like if you're actually trying to debug things on a device that you can't reproduce on on a web browser itself. One last point about mobile development. I don't know if people are familiar with this meta tags in the head that tell the browser that you are a mobile-aware app. There's actually a couple different ones. Apple started off with these, so Apple has a set of meta tags that go in the head of your document. Chrome will look at those, but it also has some others that are more, less vendor-specific. And I believe there's now a new thing called a manifest, which I haven't looked into very much. But if you go to this bit.ly link, bit.ly/add-home screen, there's a long article that explains all the different standards about how to make sure that if a user is adding your mobile web app to the home screen of their phone, it will actually now behave a little bit differently. So, example, when you open it up, here you see the sample app, and it opens up full screen without an address bar, and so it looks more like a native mobile app, which is pretty cool. So that is all I had for that. And if you want to go do these slides are at actually that bit.ly link is wrong. I think the bit.ly link is now bit.ly/GDG-Polymer2. I had a permission problem with the first slide deck. So if you want any of the links from these slides, you can get them. And so now what to do next? So we didn't have a specific code lab that we're going to recommend that you do. And so we thought we'd basically propose that you do a number of optional activities. One would be go back to that, it's academic, and there's two other really good code labs on there. I would say a really fun one to do that's also simple is the Google Maps code lab. And Jan kind of referred to that earlier and showed how, it's just really simple to get like a kind of a complex API working with even like no code at all. So that's kind of fun to see that and play around with that one. And there is also one called the mobile site with material design. I think it's like the fourth code lab on its academic site. And that one, if you want to really like build a mobile capable app that has a slide out drawer panel and see how the interactivity works with the touch interface with all the paper elements and material design elements, it's a really good exploration of those elements, and you'll kind of learn about how they work and how you put them together. But you don't have to do those. The other things I would recommend is even just poking around at some of the repositories of Polymer elements out there and just exploring, because obviously, if like Jan said, if you're going to be thinking about composing things and not trying to reinvent the wheel, you have to know what's been invented out there already. So I would go to polymerproject.org, look at all the paper elements. There is a site that Google is creating on GitHub called Google Web Components, and this one is basically people kind of working their way through all the Google APIs and making Polymer elements that wrap those and expose different of the Google services through Polymer elements. And obviously Component Kitchen, taking a look at what they have there, and find something that looks cool to you, and just try playing around with it. So we have basically this room until about 4 o'clock, I think, when we're going to wrap things up. So at 3:30, I thought we'd all get back together for a final wrap up and a demo. Come see me, and we have a little bit of extra gift for people who do demos or want to share. Either it could be something you wrote or just something you started playing with and thought was cool and wanted to show other people, or a problem you found. We'd love to have people share stuff like that. Any other suggestions for people? What they should do the next hour and a half?
Well, yeah, like your suggestion, build your own element. I think it'd be interesting to take some small problem and try to create an element from scratch.
Yeah, that would be great if you had an idea for your own element. And you have one of the best experts in this area now to actually help you with that and get you started. So that would be a really awesome thing to do. Okay, great.